Here is our new grammar for curly. We are adding a record form, a get form, and a set form. As we said, it's open curly record to create a literal record. Then we have any number, that's what the dot dot dots mean, any number of symbols combined with expressions. You can put an arbitrary expression for a field's initial value, and we'll need to interpret that. On the get side, we have an arbitrary expression to go get an object. Often it's just a variable name to refer to something that's bound to an object, but it could be a function call or anything else. And then it's always a symbol that we use to we specify a particular field name by just writing a symbol down. It's not an expression that we compute because we don't have symbols as values, for one thing. Set, similarly, it's an arbitrary expression to get the record that we're going to set in, and an arbitrary expression for the new value of the field in the updated object. So running through a few more examples, here again we have record as an expression on the right hand side, binding r, and so when we get x out of r, then we're going to get a 5, of course. Or if we looked up y, we would get a 2. These can be arbitrary expressions for the record declaration, for a literal record creation. So this 1 plus 1 needs to be evaluated to 2, and that way when we get the y out of it, we'll get a 2 instead of a plus 1, 1 expression. We can put record anywhere since it is an expression, so we could put it inside of a lambda. In this example, we're binding make to be a function that takes v and creates a record based on v. The x field is initialized to v plus 1 and the y field is initialized to v plus 2. So here is where I have get and I have an arbitrary expression in place of the object expression. So make2 is going to make a record where the x field is 3, so when I get x out of it, that's why we get 3 as the result here. You can even put record literally next to get. So this is similar to left lambda, which you wouldn't generally write, but you could write it. And happens conceptually in the process of evaluation that we can have get on a literal record that has an x and y field. So if we get x, then we'll get a 1. Since record is an expression, it can be the whole program. So what happens if we evaluate just record x1, y2? Then we need to get some sort of record value back. So that tells us that we need to extend our value data type. The same thing happens with set. So here I've got a literal record and then I set x to be 5. Set, since it's implementing functional update, it has to return a new record. So in this case also, this whole program should end with a record value. In this case, the ending record has x is 5. It also still has y as 2. So with all of those things in mind, this is our new record expression and value data type. We've got record e, get e, set e, pretty much following our grammar. One detail is that in record e, the grammar had a list of combinations of names and argument expressions. It turns out to be convenient to split up those lists and put them in parallel. So my record e has a list of symbols for all the names in the record, and then the list of arguments for all the expressions. And the first symbol here is supposed to be matched up with the first expression here, and so on. These lists will always have the same length for it to be a sensible record e, even though we can't express that in the type. Meanwhile, we have values. Values are still numbers and closures, or records. And once again, I have the names and the values in parallel here. So notice that rec v is similar to record e, and that we have two parallel lists. But for the expressions, we had names and expressions. And for the value, we have names and values.